My name is Mr. David, and today we are looking at law of definite proportion or constant composition. All right, what does this law state? It states that all pure samples of a particular chemical compound contain the same elements combined in the same proportion by mass. Again, all pure samples of a particular chemical compound contain the same elements combined in the same proportion by mass. So, what does the law mean? It means that when you obtain a pure sample of a chemical compound, be it water, be it copper 2 oxide, be it anything, so far the substance is pure, eh, the elements that are combined are in that compound are in the same proportion by mass. So it also means that if you get, let's say for instance now, pure water now. So the formula of water, the chemical formula of water is H2O. So when you get pure form of water, any wherever you go in the world, the uh the combination will always be H2O, that is two hydrogen to one oxygen. Now if you take the molar mass of hydrogen, that's 2 gram there. So and oxygen is what, 16 grams. So it means that water anywhere in the world, it has 2 gram of hydrogen, and it has 16 gram of what, of oxygen combined together. All right. So how do we now confirm verify this law? It's very easy to do. We can verify this law by preparing chemical compound via various or separate method. So that is, let's for this lesson, let's look at the how to prepare copper 2 oxide, you know, using two different methods. Let's say we have sample one, sample A now, sample A. So how can we prepare copper 2 oxide? It's very easy. We can prepare copper 2 oxide from copper triisocarbonate 4. Okay, this is solid. We'll put solid here. Then we can put this in a crucible and eat it. So what happens is that it's going to decompose into copper 2 oxide at carbon 4 oxide. Okay, so how do you know the reaction is gone to completion? You are going to eat very well anyway, and this one is going to be a solid, and this one is going to be a gas. This gas is going to be evolved. Then how do you know? It's going to change from a fairly blue color to black. Okay, you're going to obtain a black residue here, a black residue. So let's move forward. So let's now look at another way of preparing another sample of copper 2 oxide. So sample B, let's say the sample B now. Sample B. We can prepare this by, let's start by preparing this first. And how can we prepare this? We can prepare this through precipitation reaction. Precipitation reaction. What do I mean by precipitation reaction? We are going to get an insoluble, and sorry, a soluble salt, that is sodium triisocarbonate 4. So we put aqueous because it's soluble, plus copper trioxonitrate 5. Okay, it's also soluble. You put aqueous. Now when you react these two together, we are going to get an insoluble salt of this copper 2 triisocarbonate 4. So this is going to be solid because it's insoluble. Now we are also going to get, okay, that's sodium triisonitrate 5. This is aqueous. Now this is a typical precipitation reaction. Precipitation reaction. Let me label it precipitation reaction. No, what does precipitation reaction mean? It means that you react two soluble salts to give you one insoluble salt and a soluble salt. Now in this case, now we are now going to filter. We are going to filter. You know that this one is soluble, while this one is insoluble. So we are going to filter very well and allow it to dry. So when you filter, this will be your residue. Am I right? This will be your residue. Why this will be your what, filtrate when you filter. Then you now take your residue and place it in a crucible. So we can also decompose it. So we now bring a residue, that's CO3. Then we apply it, put it in a crucible, then apply it. So it's going to decompose into copper 2 oxide, solid, plus CO2 gas. solid. Okay. Now, having done that, we are not going to stop here. So we are going to move forward by turning copper 2 oxide into copper. So how do we reduce it? It's very easy. We will just take the two samples and reduce them. So how do we do that? We will just take a sample A. Let's say sample A now. Sample A. We will place this in a boat and put it and allow a stream of hydrogen to pass through it. So we reduce it by hydrogen. That is, you will say this plus hydrogen gas is going to give you metallic copper plus water. So this is what we call reduction. You add hydrogen to it and you remove oxygen from copper 4 oxide. Sorry, copper 2 oxide. Okay. So we are going to reduce it by adding hydrogen to it for sample A. Same thing goes for sample B. As is copper 2 oxide plus hydrogen gas to give you Cu plus H2O. Now, how do you know the reaction has gone into completion? You know, this one is black. So, why this one is maybe red or reddish brown? All right, copper is red or reddish brown. Okay, so that's how you know that the reaction has gone into completion. Now, how do you now? Well, we won't stop here. So, how do we now prove that this uh this obeys law of definite proportion? Now, we are going to analyze each sample. We are going to analyze each sample. Okay, now let's do the analysis. All right. Now, this is sample A, this is sample B. Now, mass of both is 3.31 gram for sample A, then mass of the both for sample B before combustion is 3.16 gram. Now, mass of both plus CuO, that's copper 2 oxide, for sample A is 5.29, while for sample B is 5.15. Okay. Now, mass of both plus ordinary copper, that is when we are done with the reduction of copper 2 oxide. So we obtain 4.90 gram. Then also this is 4.76 gram. Now, mass of CuO. How do we get mass of copper 2 oxide? It's very easy. You will subtract mass of both this from this. That's mass of both plus copper 2 oxide minus mass of both. So by the time you subtract that, you are going to get 1.98. 1.98. Let me write it here. Now, so this minus this will give us 1.99. 1.99. Mind you, they are in grams. They are in grams. So how do we now get mass of copper? Easy. Mass of both plus copper minus mass of both. All right. So that is this minus this is going to give you 1.59. Let me write it here. 1.59 gram. While uh this minus this is going to give you 1.60 gram. Now, so what do we do next? Now, what we can use to prove that their composition is the same or similar is we are going to use percentage composition. We are going to use percentage composition. So what do I mean by that? It means that we are going to find the percentage composition of copper in CuO for each sample. All right. That is, we are going to get for this one, we are going to do for sample A, for sample A, sample A. So what are we going to do? So we are going to do it this way. That is Cu over CuO times what? 100 over 1. Now, mass of Cu here is 1.59 over mass of CuO, that's copper 2 oxide, is 1.98 times 100. So by the time you do that calculation, it's going to give you 80.30%. Okay. Now for sample B, same things. Cu over CuO times 100 over 1. So our Cu here is 1.60, then CuO is 1.99 times 100 over 1. We give you what? We give you 80.4. Now, if you look at the values obtained in this case, if you look at the values obtained in this case, are they not close? They are close. So they are close. It is approximately 80% here. It is also approximately 80% here. So they are close. It means that this each copper 2 oxide it consists or sorry contain 80% of copper, while the remaining percent is what? Oxygen. That is 80% of copper, 20% of oxygen. So now, the percentage copper residue in the two samples is approximately 80%, you know. So irrespective of the method of preparation, so it's still almost the same thing. So what will be our conclusion? In conclusion, it means that CuO, in pure CuO, all right, copper and oxygen are always present in definite proportion by mass of approximately 4:1. How do we get the 4:1? It's easy. You know, copper, copper is 80, oxygen will be what? 20. So divide by the smallest, that's one. Yeah, 4. So 4:1. Thank you.